In the video you're about to watch, Dr. Akoff Russell uses cars to explain systems thinking. What is a system? A system is made up of independent parts that can affect the system's behaviour or its properties. Consider how this might relate to you and your team and its safety as you watch.
I read in the New York Times recently that 457 different automobiles are available in the United States. Let's buy one of each and bring them into a large garage. Let's then hire 200 of the best automotive engineers in the world and ask them to determine which car has the best engine. Suppose they come back and say the Rolls-Royce has the best engine. Make a note of it. Which one has the best transmission, we ask them, and they go run tests and come back and say the Mercedes does. Which one has the best battery? Come back and say the Buick does. And one by one, for every part required for an automobile, they tell us which is the best one available. Now we take that list, give it back to them, and say remove those parts from those cars, put them together into the best possible automobile. Because now we'll have an automobile consisting of all the best parts. What do we get? You don't even get an automobile, for the obvious reason that the parts don't fit. The performance of a system depends on how the parts fit, not how they act taken separately. You see, the architect, who's the profession that I think understands systems best, really has the fundamental idea. When a client comes in to see an architect and they say, I want to build a house for my family with 3 bedrooms, a living room, dining room, and kitchen, a family room, a 2-car garage. I want it on 1 floor. I'd like it to be built out of redwood, and I don't want it to cost more than $10,000. What does the architect do? He has a set of properties that the client wants. Does he sit down and start to design the kitchen, and then the living room, and then the bedrooms, and then the garage? Is that what he does? Of course not. What he does is produce an overall design of the house. Now he produces designs of the rooms to fit into the design of the house. But he discovers in the process that he can modify the house in such a way as to improve the quality of the rooms. But he will never modify the house to improve the quality of the room unless the quality of the house is simultaneously improved. And that's fundamentally the principle that ought to be used in continuous improvement.
So, who or what do your team rely on to be safe? What are your interdependent parts? How well do those parts fit together and keep you safe? What parts can you control or influence to improve safety in your place of work? Who could you engage with to expand your control or influence? Thinking in systems opens up questions like these that can improve safety for you and your team. So where in your system will you start?